Hey everybody, today we're replacing the motherboard in a Gateway W350A laptop, and this is the notebook that we're going to be working on. First thing we're going to go ahead and do before we start making repairs is to go ahead and remove the battery. And set to the side. And of course also if your AC adapter's plugged in, unplug it too. And then also go ahead and press the power button, hold it for a few seconds to make sure that the components are fully discharged. The thing about laptops is not one goes together exactly the same. They all follow a similar way of being assembled, but none of them are exactly the same. On some laptops you gotta completely disassemble the entire thing just to change a memory module, such as in my Acer Aspire 1 netbook. Most laptops allow you to change a memory with just taking off the door, but you have to take the whole thing apart just to replace your CPU. While some, like this machine here and my Dell Inspiron 1525, allow you to change out the CPU, Wi-Fi cards, memory, hard drive, that kind of stuff by just taking off one of the doors on the bottom of the machine. This computer has two doors to access the internal components, and usually when I take apart a laptop I'll go ahead and remove the memory before taking out the motherboard, but in this case I can take out the memory and CPU along with the Wi-Fi card, which is actually one of the things you take out normally. I'm just going to take these doors off and access the inside of the computer. So we have access to our memory, CPU, and CPU core under this door. Removing this door allows us to get to our hard drive and Wi-Fi card. So first I'll go ahead and remove the memory. Which laptop memory is pretty easy to install and remove. This is DDR2 and DDR3 looks identical to DDR2. I'm going to set the memory to the side. Now let's figure out how this CPU core comes off. We appear to have a screw here, a screw here, plus 4 more screws that hold the heat pipe cooler over the CPU. Let's go ahead and take those out. Something is holding this cooler back, so I'm going to go ahead and disassemble as I normally do, and then come back to this one, get the board out of the machine, because usually these are attached directly to the motherboard. It doesn't hurt to go ahead and remove the screws though. I'm going to take out the hard drive. The way the hard drive goes in this machine is a little different than usual. On the door there are two screws that secure the hard drive in place. You want to take the door off, there are two more screws that hold it in place, and then when you take those screws out and the hard drive slides down, and you have to kind of pry it out of place. There's a hard drive, 250 gig hard drive. This is kind of a mid-range machine with a dual-core CPU. Not bad for, I believe it came out in 2009 or late 2008, something like that. I'm going to take out the Wi-Fi card. Which this laptop has an extra mini PCI Express slot available for, let's say, a Bluetooth card, or a card for wireless, for, like, let's say from a cellular company, cell phone company like Verizon or something like that, for their mobile broadband. It's pretty neat. And one of the extra things that I do when I disassemble laptops when I get to the Wi-Fi card is I go ahead and I take a picture of how these two wires hook up to the Wi-Fi card, so that when I go to reassemble this thing, it's very easy just to look back and see how it went together. So I'm going to take a picture right quick. Take one more. Now I'll go ahead and pop these loose. Which it doesn't hurt to do this before you take the screws out, but either way it doesn't really matter. This is the Wi-Fi card. This is responsible for your Wi-Fi connectivity. Next thing we're going to do is remove all the screws on the bottom of the machine so I can get the keyboard, touchpad, palm rest, everything loose. Now I'm going to remove the screw that holds the optical drive in. I'm going to slide the optical drive. It's pretty simple. Just pulls right out. Which, notice, this is actually an HP drive. That's because I replaced the drive in this computer as a troubleshooting step, and that did not resolve the previous problem with the motherboard. So obviously the motherboard has got some problems. Double check, make sure no more screws on the bottom of this machine, and disconnect this little ribbon cable. This goes to the touchpad. ahead and flip the laptop back over. Open up the lid so we can access the keyboard, palmrest, touchpad, all that sort of stuff. Open as far as it'll go. Now that the screws are taken out of the palm rest and everything, these plastic components should snap out, but still be careful because they can be pretty tricky, and also, not to mention, fragile. It's something you don't want to break. I couldn't find a schematic on the internet on how this machine comes apart. Sometimes the keyboard may come out first. It really depends. It appears that the palm rest and everything comes out first. This had some pretty tough snaps in there. I'm going to take out this ribbon cable. Things can be very tricky to get out. Actually, I'm going to see if this one connects to the motherboard somewhere. I'll take it out. Keyboard just comes right out. And it's going to disconnect its ribbon cable. Set the keyboard to the side. And yes, these buttons here, the ribbon cable going to them, does have a easy to get to connection right here. So go ahead and disconnect the ribbon cable on the motherboard. Set this to the side. Go ahead and remove the screen. First I gotta take some screws out the back. There's one here and there's another one down here. We're gonna take those out. Before I take the monitor completely loose, I'm going to disconnect this video cable. And of course, be very careful with this cable because there's a bunch of itty bitty little connections on this cable. You don't want those to get messed up. And now we have 4 screws to remove that hold the screen onto the laptop. Well, I already removed 2 extra screws in the back, so it's actually a total of 6 that you have to remove. I'm going to open the screen all the way because the screen's going to come completely loose as soon as I loosen all 40 screws. Okay, well I figured out how to get the screen off, and it was like I originally thought. The screen comes out first, and then the palm rest and everything comes off. The screen wasn't very easy to get off either. You have to be very careful because these little things snap in right here, and they're not easy to get out. So anyways, let's go ahead and take this palm rest off. Okay, finally managed to get the palm rest off. And fun to note, there is a hidden screw right there. So be sure to look out for that when you go to remove your touchpad. It's funny, there's not one on this side, but there is one on this side that they got almost hidden out of the way over here. So anyway, I finally got that off so I can move on. Finally, we have access to the motherboard. You're going to remove all the screws that are holding the motherboard in place. I believe only one screw is actually holding the motherboard into this chassis. The rest of the screws are for the other components that are attached to the board. So just carefully try to pull this board out of place, which can be a pain sometimes to do. But it's like nothing ever wants to work like it's supposed to. Now we'll carefully remove any remaining cables, such as our modem cable. And I'll have to detach the modem here in just a moment. We have a ground screw to remove. Go ahead and take that out. Go ahead and take the modem off so I can access the plug a lot easier. funny, this right here, if you can see, this is the telephone modem inside of a notebook. Incredibly small. I'll leave the cable attached to it because I don't think the motherboard I got off eBay includes the modem. So now we're going to take off our CPU core, which I've already, if you remember back earlier in the video, I went ahead and took loose the other screws that were holding it on. So let me double check and see if there's anything else holding this thing onto the board. There's not, it just pops right off. And let me tell you something else. You gotta love how they just use this really junky thermal paste on the CPU, and they use what I like to call thermal pillows and everything else. It's basically what they use, and these don't do a very good job, in my opinion. Notice, if you can see here, there's a gigantic hole in the center of this thermal pad. So that means it wasn't making very good contact with one of the chips. There's the rest of it on the actual chip. The real problem with these thermal pillows is the simple fact that they're thick, and when you go to reinstall your cooler, some people will like to take these thermal pillows loose and put thermal paste where the pillows used to be, and you would actually there would actually be a gap between the heat pipe and the chip, so it wouldn't actually cool like it's supposed to. Anyways, go ahead and take this off. Okay, so before I continue on, it's really funny to note that this cooler had two thermal pillows, one here and one here. Let's go ahead and have a look at this motherboard. There's only one chip that's getting cooled. You can see it's right there. That's it right there. And it's funny enough that those two thermal pillows, one was being used on the chip and the other was not being used at all. So what I did was I transferred it over from its original spot over to where the Northbridge chip is, as you can see here. And I just want to show you guys something else too that really disappoints me in a way. Notice here, this is our Southbridge. This motherboard has an AMD chipset, by the way, and this is our graphics Northbridge. It's getting cooled like it's supposed to, but this one has no cooling at all on it. And I've seen this in a newer HP laptop with the AMD chipset, and I saw this in a HP laptop with an Intel chipset. The Southbridge, looking similar to this, was not getting any sort of cooling at all. Used to be, back in the day, the Southbridge never had a heatsink on it because it didn't get that hot. I mean, way back in the day, neither chip had a heatsink on it. Nowadays, in most desktops, the Northbridge chip has a heatsink installed, and so does the Southbridge. Used to be it was just the Northbridge had a heatsink installed, but now they decided to do both the Northbridge and Southbridge. And let me tell you, these newer Southbridge chips do get pretty hot, and that's referenced by touching the heatsink and feeling how hot it gets. Just imagine the chip with no heatsink installed, how hot it gets. It's not very good, at least in my opinion. Anyways, we're going to continue on. Okay, last thing we're doing with this motherboard is taking the CPU off. This is an AMD Teardown 64X2 processor. And any laptop CPU nowadays is installed like this, whether it be Intel or AMD. The socket has a little screw-like locking mechanism. You turn it to the left to unlock it, you turn it right to lock it. So we're going to turn it left to unlock it. Make sure it's turned all the way. Now it's unlocked. The CPU just lifts right out. And it's funny, AMD has been using this socket S1 for quite a while. I mean, ever since like 2007 or so, they've been using this, but newer AMD platforms, I believe, do have a different socket, but this socket S1 has been used for quite a while. I mean, machines from 2009, Windows 7 on them, a Sembron machine actually had socket S1. This machine has socket S1, and the HP DV6000 I worked on a while back has socket S1. So this is a laptop CPU right here. There's no heat spreader installed because the CPU die, which is the actual processor core, this thing right here is cooled by the heat pipe that goes across it, so there's no need for a heat spreader. So anyways, going to unbag the other motherboard and show you it, and pretty much everything from here on out will go in reverse, but I will show a video of me installing the processor and the core. Okay, as I had just previously mentioned, I was going to shoot video of me installing the CPU and core on the replacement motherboard. And here's our replacement motherboard. And the reason why I'm shooting video of me installing the processor is because there's some important things you got to look out for when you're installing laptop CPUs and their coolers. So basically, installing the CPU is very similar to a desktop. Of course, to make sure everything is unlocked, which it is, I think. Yep, it's unlocked. So we'll go ahead and drop this in. And of course, when you're working on laptop CPUs or any AMD desktop CPU, unless it's a server processor, modern server processor, you gotta watch out for the pins on the processor. But if it's an Intel CPU or a very recent AMD server processor, you gotta watch out for the pins on the motherboard. Turn this screw head and it locks the CPU into place. I'm just double checking to make sure it's actually locked down. And as I was referring to the pins on the processor, older Intel CPUs also have pins, so watch out for that too. Any laptop processor, as of now, has the classic setup with pins on the CPU, so watch out for that when you're installing it and handling the CPU so you don't break the pins. Okay, now it's time to install the cooler. First thing I'm going to do is make sure this CPU is good and clean. This is very important for CPUs with exposed dies or cores. And you also want to be careful because this die is very fragile. You do not want to fracture that. Used to be back in the day during the Athlon XP days and the Pentium 3 days, these things were getting fractured left and right. I never fractured one, but I've heard stories, horror stories of people fracturing their dies when installing their heat sinks. So you always want to be careful with these, because you don't want to fracture them. Thermal compound that they used dried up really good. So I'm sure it wasn't really doing its job very well anymore, because it's caked on that CPU very good. Normally paste don't get like that. It's the cheap stuff they install on CPUs nowadays that gets on my nerves. This is nowhere near as bad as the bubble gum they use on desktop chipsets and some video cards. Sometimes it can get so bad where you have to take a razor blade to get it off. That's another possible way you could fracture your CPU die. Okay, now the CPU die is good and clean. There's still some stuff around the edges on the sides of the die where it rises off the PCB, but at least now it's clean enough where we can install thermal paste and get a good connection with the heatsink, with the heat pipe core. Now I'll show you the bottom of the core, how it looks, so we can clean it up too. Here's how this looks. It's quite a mess. And this is the thermal pillow that I have moved over to replace the bad one. And of course this in here was never used because the extra chip was not an option, was not installed on this motherboard. Now I gotta get this junk off of here, which will not be very easy to do. Yeah, this stuff has definitely aged quite a bit. And it's funny, when this stuff here is new, it's very hard to apply. Usually the coolers come shipped with the stuff pre-applied, and it just give it a few years and it just crumbles up and doesn't do its job very well anymore. It's pitiful. Absolutely pitiful. Okay, it's finally cleaned up and ready to go. Now I can go ahead and install our cooler. Okay, now I'm going to apply some thermal compound to our CPU. And to some of y'all, it will remind you of going back into a time machine and going back to the year 2001 and applying paste to your AMD Athlon CPU or your Athlon XP CPU if it was a couple years later. Because basically you have a CPU die rather than a heat spreader, as I was mentioning earlier. So it requires a lot less thermal paste. That right there is all you need. And be sure to use non-conductive paste on something like this. And of course nowadays on heat spreader CPUs, if it's a high-end machine, I'll use Arctic Silver 5, but that paste has silver in it. And I'm not necessarily sure about how conductive it is, but when it comes to CPUs with dies or chipsets, use non-conductive paste, such as this basic paste here, which works pretty good on laptop CPUs. I've used it plenty of times. I'm going to try to get a thin coat across the entire CPU die. Now I'll go ahead and attach the cooler. And I'm also going to double check and make sure that it lines up with the chipset die. Make sure the thermal pillow lines up with the chipset die. And it will, so we'll go ahead and apply this cooler. There's a total of 7 screws that hold this cooler into place. As I mentioned in the beginning of the video, pretty much almost every laptop out there is different in some sort of way of assembly or how the cooling system works. In this case, as I mentioned earlier, I mentioned about the assembly of the machine, but also they differentiate on how their cooling systems are designed. Some of them are designed very good, others are not designed so well. This one has a pretty decent design. Before I wrap this video up, I'll talk about why I believe the original motherboard started acting up. Okay, now the CPU core is installed, let's go ahead and plug in the fan. Never forget to do that. Now it's just a matter of putting the motherboard back into the machine as it was, pretty much in the reverse order of how I took it apart. So anyways, that is how you tear down the Gateway W350A laptop to replace your motherboard. And after I get this thing reassembled, I will go ahead and start it up and show you how everything looks. The reason why I'm not going to be shooting video of me putting it back together is because there's a lot of guesswork involved in reassembling the computer. Because you have to recall back into your memory which screw goes where and all your connections, just a whole bunch of stuff. So anyways, I'll have some extra video of how this thing looks after I get it back together. Okay, another day. Well, it's the next day actually. Well, now I have got the replacement motherboard installed into this computer, and the problems that were occurring before are no longer occurring now. Started right up, didn't take long at all to post. Took the average time you would expect for a computer to run through the post test. So I pressed F2 and went straight to the BIOS. It's detecting both the hard drive and the optical drive. So now the motherboard in this machine is working fine. Okay, now since the computer is back in one piece and it's working just fine, then we're going to talk about something I had mentioned earlier in the video that I was going to discuss before the end of this video was up. I'm going to explain why I believe the motherboard in this machine failed. So when it comes to laptop motherboards, there's usually 2 reasons that cause them to fail. One reason being the cooling system, and that's probably one of the most common reasons with laptops nowadays and even back into the mid 2000s. A lot of times the cooling systems are not designed very well. They'll use a very small heat pipe for both the CPU and Northbridge, and sometimes a single heat pipe for a CPU, Northbridge chip, and a discrete graphics processor if equipped. That's a very bad design. And sometimes they will use a single heat pipe, and what they'll do is they'll have the Northbridge, GPU, and CPU not in the correct order. So more or less they'll have the CPU at the end of the heat pipe, so heat comes off the CPU, travel across the Northbridge and the GPU before going to the fins of the cooling system. That's also a very bad design. That's the way the design is in the HP DV6000, which is a failure-prone laptop from HP. And with the DV6000, for example, there's also another issue. the heat pipe doesn't make very good contact with the Northbridge and graphics processor, if equipped, because GPUs were an option on the DV6000s, because the motherboard has a spot where they could be installed. Anyways, basically the heatsink or the heat pipe core didn't make very good contact with the top of the Northbridge die, and they used a thermal pillow between the Northbridge die and the heat pipe, and there wasn't very much pressure applied to that Northbridge chip. So what would happen is over time the Northbridge would get extremely hot, and the solder below the chip would actually form microcracks. This is lead-free solder, by the way, and these microcracks would cause all sorts of random types of failures, ranging from this very poor performance to a non-working machine that just, when you try to turn it on, it just spins the fans and does nothing else. And I've seen that common with some machines. And another common thing that occurs with the cooling system, which I believe is the most common thing over faulty cooling systems, is the cooling system itself. The fins are located in this area. Sometimes they're located around the back, and the fan is located in this area. The fan sucks air from the bottom of the laptop and blows it across the fins. And the fins are designed where they're very small to transfer heat very fast, to get rid of the heat as quick as possible. So what happens is these little bitty fans catch dust and clog up very, very easily. So once they get clogged up by dust, air cannot circulate, and the computer will start to overheat. And usually what will happen is the fan will run wide open to try to compensate, and eventually the fan will wear out. And I've seen this happen a couple of times too. Another common thing about the cooling systems is, well, on this laptop the intake is not necessarily right under the fan, but most laptops there's an intake for the cooling fan that's right under the bottom of the machine, and people will set their laptops on their beds or to some kind of soft surface where air cannot get up under the machine to cool it. It's very crucial that if you're using a laptop on anything other than a solid table, to use one of those aftermarket cooling pads to set your laptop on, or even something as simple as a book. Just something that air can circulate under the laptop to where the cooling system can get air. Okay, I just got finished talking about cooling system. Now let's talk about the second big reason that I think could have caused this motherboard to start acting up. Nowadays, computer components and the other electronic devices are what's called RoHS compliant. So they use lead-free solder, and they're supposed to be greener for the environment. It hasn't been that long ago since I uploaded a video to YouTube of a small Acer machine that was manufactured in 2008, so it was 4 years old, dead. Didn't even want to start. I mean, you press the power button and it'd spin the fans. It's a classic sign of a motherboard failure. And that machine had inadequate cooling, plus the fact that the motherboard was RHS compliant also led to its failure. Lead-free solder, in my opinion, is just not as reliable as traditional lead tin solder. The thing about lead-free solder is it tends to crack very easily, and I've seen so many motherboards that use lead-free solder not working anymore, and many of those motherboards are only a few years old. It used to be back in the day with motherboards that use traditional lead solder, they just keep on lasting. The computers themselves will just keep on working and not fail, and eventually get to the point where people would have to just donate their computers in and go buy a new machine because the computer just kept on working. And I'm sure there are a bunch of these old computers around today that are still working just fine. You can find them at thrift stores and other places. Nowadays it seems like the computers that are RoHS compliant seem to fail at a very premature rate. Some of them don't even last much longer than the 1-year warranty that comes with them. So anyways, those are the two reasons why I believe the motherboard in this thing could have failed. And for any matter, for any laptop motherboard for that matter, that's probably the two biggest reasons that would cause a laptop motherboard to fail, and in some cases a desktop motherboard. And at least reason number 2 for that matter. So anyways, I have successfully replaced the motherboard in this Gateway W350A laptop. If you have any questions or comments, feel free to ask.